Let's continue with our lesson. In this video, I will be introducing now an additional rule in our list. So in the last lecture, I have discussed there the rule using, if your conclusion is a conditional statement, then you can use what we call the conditional proof. And if you will just have a quick review for the conditional proof, again, that is only applied if your condition or your conclusion is a conditional statement. And what did we introduce there? The if clause will become a new premise and the then clause becomes the new conclusion. And for today, for the indirect proof, we will not be very particular in the conclusion, unlike for the conditional proof. Conditional proof, the conclusion must be a conditional statement. But for the indirect proof, you can have any conclusion given. And what we will do for the indirect proof is simply, the first step is, whatever conclusion is given, we negate that conclusion, making it as a new premise. So for example, we have our premises, and then we have our, let's say, conclusion Q. So this is our original conclusion. So for the rule of indirect proof, we will now negate the original conclusion, and then the new conclusion will now be the false value 0. The negation of the original conclusion becomes a new premise. It's an additional premise from the premises given, and then this will now become our new conclusion. And since our new conclusion is the false value 0, we need now to come up with a contradiction somewhere along our proof. Therefore, what we desire to find in our solution is a proposition, let's say any proposition P, and its negation. Because when we combine P and not P together, this will be equivalent to our false value 0. And where did we find this? We have this under identity rule. For the rule of indirect proof, whenever conclusion is given, what we will simply do is negate conclusion, making it as a new premise. Then our new conclusion will become our false value 0. And our goal is somewhere along the proof, we must find two propositions, not necessarily single propositions. You can have compound propositions as long as we have one proposition being negated by we will find the negation of that proposition in another premise. Then we just combine the two propositions using conjunction, which will now give us a false value 0 based from the rule of replacement called the identity. Again, what we want to arrive at is a contradiction somewhere along our proof. Let's get into some examples. I think we can solve the homework using also. So let's show that the homework is solvable also using our indirect proof. And let's go to the first example. In our first example, or in the first problem in our homework, the first line is the negation, not of P implies not Q and R. And then our conclusion is P and Q and R. So we only have one premise. This is our conclusion. So according to the rule of indirect proof, whatever conclusion is given, what we simply need to do is to negate that conclusion. And when we negate that conclusion, this becomes a new premise. So we now label this as 2 because we have only one premise. And then our new conclusion will now be our false value 0. So this is using the rule. This is now using the rule of indirect proof. So this is using the rule of indirect proof. So again, we want to come up with a negation, or we want to come up with a contradiction somewhere along the line of our proof. Okay? And this means that we will neglect this line first. The original conclusion will be neglected for a while. Why? Because our new conclusion now is this. This is our new conclusion, the false value 0. And this is now our new premise coming from the original conclusion. And what can we do? If you like to imitate what we have done in the homework, from proposition number 1, we can use material implication. And if you will recall in the homework, material implication for line number 1, that should give us not P or not Q and R. This is using material implication of premise number 1. And after doing the material implication of premise number 1, sorry for that, what can we do next? Remember, we want to come up with a contradiction. Look at this. We can use De Morgan's law in premise number 3 because it's preceded by a negation here. So if we will use our rule of negation, De Morgan's law, this will now become So that will now become not P and not of Q and R. This is using De Morgan's law of premise number 3. Then after using De Morgan's law of premise number 3, by double negation, we have P and Q and R. Double negation of line number 4. And look at what we have here. Isn't it that the resulting premise here is the negation of premise number 2? Or you can have it also vice versa. Premise number 2 is the negation of premise number 5. So there you have the contradiction. So if we now combine the two, we get P and Q and R and not P and Q and R. What rule? We just combine the two. So that's conjunction of premise number 2 and premise number 5. And because of premise number 2 and 5 combined together, we now have our contradiction that will give us our false value 0. And this is now using identity property under line number 6. So we have, look at this. This is now treated as a single proposition. You have your P and not P. And P and not P is equivalent to 0 using the rule of identity. Well, it's longer compared to the original solution that we had in the homework, but at least we have here an alternative solution. Again, for our what happened there? For our indirect, you do based from your original conclusion, that becomes a new premise, and then your new conclusion will be the false value 0. Your desire is to come up with a contradiction so that when you propositions together, you will now have false value 0. Another example. Let's proceed with the second example in the homework. Premise number 1. We have P or Q implies R and S. Then we have P as the second premise. Our conclusion is R. By the indirect proof, according to that, we negate the original premise. This becomes a new premise. And then, this is now our new conclusion. The false value 0 becomes the new conclusion. And how do we now treat this problem? What will be our fourth premise? If you would like to imitate what we have done in the first problem, or in the first solution for this problem in the homework, we can add first Q. So we have P or Q. This is just using addition for line number 2. By the way, this is by indirect proof. Here, this line here is for indirect proof. And then, after adding Q to P, we can now use modus ponens. That should give us R or S. Modus ponens of 1 and 4. Then after using modus ponens of 1 and 4, remember we want to arrive at a contradiction. So if we will simplify this, we have not R is a new premise. So if we simplify this, this leaves us R. Simplification of line number 5. And after simplifying number 5, we now arrive at a contradiction. You have here not R, you have here R. So, R and not R, this is by conjunction of line number 6 and line number 3. And because of that, that now gives us 0, or our false value 0, using now identity. Identity of line number 7. There goes your contradiction. Let's also do the third example that we had in the homework. Third example in the homework. premise number 1, we have P or Q, P or Q, or not R. Premise number 2, not P and not Q. Therefore, not R or S is our original conclusion. Solving this using our indirect proof, step 1, whatever conclusion is given, just negate that conclusion. And your new conclusion becomes your false value 0. This is again by indirect proof. So using indirect proof, we have that. Next, what can we do next? Remember, we have a new premise here, we have a new conclusion. So disregard the original conclusion. We don't need that in our solution. And what can we have here? Let's imitate what we have done in the homework. Using De Morgan's rule in premise number 2, that becomes not P and Q. De Morgan's rule for line number 2. So after using De Morgan's rule for line number 2, we can now use disjunctive syllogism for 1 and 4. So that should give us not R using disjunctive syllogism for 1 and 4. Then after using disjunctive syllogism, this is not R. We can add S proposition. So this is by addition in premise number 5, giving us not R or S. This is not R or S. This is not of not R or S. So there goes your contradiction. So you have not R or S and not R or S. Conjunction of line number 6 and line number 3. And finally, this is now your contradiction that will give you your false value 0. Reason here, we have identity in line number 7. So we have seen here that even in our previous problems, we can use the indirect proof. The indirect proof can be used for any given conclusion. Unlike for the direct proof, the direct proof can only be used if you have a conditional statement. I mean, the conditional proof can only be used if you have a conditional statement in your conclusion. Okay. There's one example given in your module. Maybe we can explain that and we can use that as our 4th example. The 4th example, the first premise is P implies Q. We have Q implies R. And then we have S implies not R. And then 4th is not S implies not T. And then we have not T implies not Q. Therefore, not P. So we have 5 premises and our conclusion is not P. So step 1, whatever conclusion is given, negate that conclusion. So you have not P is given, so negate that, it will become not P, and then our conclusion, new conclusion will be 0. This is by indirect proof. And then let's rewrite our new premise not P. That's the same as P. Using double negation, we just simplified. We just removed the 2 negations there. So that gives us P. What's next? Where do we find P? P can only be found in the first premise. P implies Q. We have P, therefore Q. Using modus ponens of 1 and 7. And after using modus ponens of 1 and 7, where do we find Q? We find Q in 2. Modus ponens again of 2 and 8. Then R. Where do we find R? R is found in premise number 3. Okay? Therefore, that should now give us S implies not R. R is given. Therefore, if we will use modus tollens, that's not that will give us not S. Modus tollens of what lines are those? We have utilized 3 and 9. Modus tollens. And then not S is there. Not S implies not T. Therefore, this is not T. Again, modus ponens of 4 and 10. Not T is in 5. Not T implies not Q. Therefore, not Q. That is using modus ponens of modus ponens of 5 and 11. We have not Q. But look at this. In number 12, we have not Q. In number 8, we have Q. We have now a contradiction. So by conjunction, Q and not Q. Conjunction for 8 and 12. And finally, we have our conclusion 0, or the false value 0, identity of line number 13. So there you have it, the rule of indirect proof. So I hope I can still save this. My phone is already running low in terms of its battery. Okay, so there you have it for our lesson for today, the rule of indirect proof. Again, for the rule of indirect proof, first step, negate your original conclusion. That becomes a new premise. Then the new conclusion becomes the false value 0. In your proof, contradiction. You must find 2 premises that will contradict each other, so that when you combine them, you get your false value 0, simply using the identity rule. Okay? So that's it for today. See you in our next activity.